In this lesson, we shall focus on MIP1502, which is a mathematics module, and we shall go through a wide range of questions as deemed necessary. First things first, we shall focus on question 4. Question 4 is part of the assessment questions that we must be familiar with, and these are the kinds of assessment questions that you'll also meet in the exam, and therefore this is very, very important. Consider each statement below. So replace the symbol phi with the relational symbol equal to, less than, or greater than. In turn, say which statements are true sentences. Okay, so we continue.
Okay.
We continue then what we need to do. Okay, for example, in this case, in 4.1.1, we have the symbol phi that has been used, and in 4.1.1, we have x phi x. X phi x.
Yes.
Now, if we're to use the equality or the less than symbol or the greater than symbol, we need to actually obviously be able to see that here the symbol that is applicable is the equal to symbol, so that x
Symbol.
is equal to x, because x can only be equal to itself, but x cannot
Yes.
be less than itself. X is not less than itself, so any number is equal to itself. I mean, as we know that, for instance, the number 2 is equal to 2, the number 3 is equal to 3. Yet now, obviously the number 3, for example, would be a number that is, you know, if one wants to record this, so we know very well that the number 3 is not less than itself, but the number 3 is actually equal to itself, and
Equal to.
equals x. X,
Yes.
X. Okay, so we continue.
Yes.
Okay, we continue.
Yes, we continue.
Right. Okay, next question. In 4.1.2, with x phi y, then what can you say about y phi x? Okay, so what I want us to do then is to be in a position to put the correct symbol here. If we have that x and y are related, then y and x are related. And the question then becomes, what is the relation here? Okay, so we continue to
Yes.
analyze this as follows. Right, so if we have to then say that x and y are related, how can we therefore relate y and x? Let us analyze this, because there are a couple of relations that we can use here, and we shall have the opportunity to use any of the relations. Now, is it less than that is applicable?
Okay.
Is it greater than that is applicable? Is it equal to that is applicable? Let us analyze these obviously together. For example, if somebody can say
Yes.
that x and y are equal to each other, can we then say if x and y are equal to each other, then what we then say? Okay, right. Okay, now in the second question, so we shall say, we can say, for instance, x equals y, x equals y. So in other words, if x equals y, we can say then y is equal to x. So this will hold true, because you see this symbol is the same symbol here, the same symbol
Okay.
phi. So if it is the same symbol phi, then we are saying if x equals y, then y equals x. So
All right.
it is true.
So
Right.
it is true.
Yes, it is true. All right. So that is what we can say here. Right. So we continue then.
Okay.
All right. So let's continue then right now with the next question. Right. Let us look at 4.1.3.
Yes.
Right. So if we then say if x and y are related by the same symbol, and y and z are related by the same
Yes.
symbol, then x and z are related by the same symbol. So we continue then to analyze that. And we have a chance then to, okay, so what then becomes the symbol here? what then do we do here? Okay, right. So let's take a look. So in 4.1.3, then we shall then say, if x equals y, so it can only be an equality here. If x equals y and y
Okay.
is equal to z,
Equal to Z.
then x is equal to z. Okay, so we continue then and have a chance to solve these particular problems here. Okay,
Okay.
right.
Mhm.
So yeah, we continue. We continue. Right. Okay, next question.
So,
Yes.
all right. So
Yes.
basically here it
Yes.
simply say that x is equal to y and y is equals to z, and then x is equals to z. So what's the answer? Is
Yeah,
it
it's,
a
co-
true statement?
it is called a
It's
transitivity.
okay.
Transitivity property.
All right.
It is called the transitivity property. All right. So
Okay.
right. So we continue then right now. We continue then right now and
Yes.
we check what we can do. Okay,
Yes.
we take now the next question. So, okay, but now, I mean, the question is that what then do we do here? So we decide what to do, but also we look at whether this is the only sign or not. Well, it is not the only sign we can use because by transitivity, we can say that, for instance, you can use the same symbol here, like less than, because if
Okay.
x is less than y and y is less than z, then, okay, if x is less than y
Yes.
and y is less than z, then x is less than y
X is less than Y. Yes.
and y is less than z. Okay, so, I mean, in 4.1, because you can put any symbol here, but you need to choose from the
Yes.
equal sign, the less than, or the greater than symbol.
Okay.
All right, so now,
Yes.
for example, okay, now you can say if x is less than y and y is less than z, it obviously means that from this in mathematics, if x is less than y and y is less than z, then it means that x is less than z. You get the point?
Yes. Yes.
Yeah, that becomes then a true symbol there. That
Okay.
becomes a true symbol there. Right.
Okay.
Okay, so we continue then. Right, so in the end, then you can think about what about if you use greater than? You know, you can say, what about if you use the greater than symbol? Would it work? So we are looking at this 4.9.3. What about if a student comes and says, if x is greater than y, okay, we're experimenting with this one, y is greater
Yes.
than z, then can we then say that x is greater than y, but y is greater than z? It means therefore y would be greater than z.
Yes.
So, and this gives us three possible
Three
answers
true
to
statements. Yes.
yes. So yeah, so there are three true statements, and the true
Yes.
statements obviously indicate that we can use a wide range of the signs.
Signs. Yes.
Yeah,
As long
definitely.
as they are all true.
Yeah, we can use a wide range of the signs that that are applicable. Okay, so we can use a wide
Okay.
range of the signs that are applicable. Okay, in this case, therefore, we have a choice. So here we can have three symbols that we can use. Okay,
All right.
yeah, we have
Yes.
three symbols that we can use. Next question.
All right.
Right, in 4.2.1, solve the following inequalities to show the solution on a number line. Right, so to solve the following questions, like in 4.2.1, solve the following inequalities and show the solution on a number line. Right. So now in the end, then you have y minus 3 is less than 2. Let us solve
Yes.
this inequality together. So now to solve this inequality, what we do is we use the property of what we call the additive inverse property. Right. So we use
Okay.
what we call the additive inverse property. What is the additive inverse property? Well, it means that if you have y minus 3, you can add 3 here, and you have 2, and you add 3. So we want to remove negative 3. So to remove negative 3, we add the additive inverse on both sides of the inequality.
Yes.
Right. So we continue then, and we solve this particular problem as follows.
Problem.
Right. So if we add 3 both sides, and if we add 3 both sides, we actually proceed to add the 3, and we've added the 3. And if we add the 3, then what then do we do?
Mm.
Right. So you have this as less than, what is 2 plus 3? It is 5.
5.
So yeah, we have then be able to solve this inequality for y. And then now we need to show the solution on a number line. And to show the solution on a number line, we have the following. Right. So we have 5 there, and y is less than 5. And if y is less than 5, then we're going to do this. And this means, therefore, that y itself is less than 5. Okay, y is less than 5. All right, so we are done then with this particular problem for
Yes.
1. Okay, now, because the question said solve the following inequalities and show
Okay.
the solution on a number line, and we have shown these on a number line there. Okay, next question.
The number line. Yes.
Yes. So, right, so we continue right now to do the next question. Right. So,
4.2.2.
right. So yeah, we continue then. We continue to do with the next one. We continue with the next question. Right. So to do 4.2.2, yeah, is the same thing. Okay, you have twice t minus 30 is greater or equal to minus 18. Let us solve for this here. Okay, now to solve this here, you have 2t minus 30, we add 30. The greater or equal to minus 18, and we add 30. Which
Okay.
is twice t is greater or equal to. Now, 30 minus 18 is 12. Okay, we added 30, and the 30 is the additive.
Inverse.
Is the additive inverse of minus 30.
Yes.
30 is the additive inverse of minus 30. Right. Right. So we continue. We continue.
Yes.
All right, we continue. Right, so in solving this particular question, we have the following. Right, so you add 30 on both sides of these. So 30 is the additive inverse of minus 30. So in the same way, you can say that minus 30 is the additive inverse, is the additive inverse of 30. The minus 30 is the additive inverse of 30. Okay.
Okay.
Right. So now then we continue right now to solve for t here. And to solve for t,
Yes.
what do we say? Right. So we then say we need to solve for t, the correct way is also using the property of what we call the multiplicative inverse. Multiplicative inverse.
So we're
Right.
using two inverse here. The
Yeah, we're using
multiple
two
and
types
the
of inverses.
okay.
Right. So Yeah, so obviously now what we're then saying here is that we use the inverse right now. And if we use the inverse, we use the multiplicative inverse both sides. So the multiplicative inverse of 2 is 1/2.
Okay.
So that we have t is greater equal to, then you take 1/2 of 12. You get what? You get a 6.
Yeah. 6, yes.
Right, so we continue then and we solve for t. And if we solve for t, we got the t is greater equal to 6, and therefore this is the t number line, or it's a number line of the values of t, and we take t greater or equal to 6, and therefore that would mean that we actually shade here and we go to the right side of 6. Okay, so okay, so we continue then to solve for t, and we're done. Okay, right. So obviously we've answered the question because the question said solve the following inequalities and show the solution on a number line.
So
We've solved for t and we've shown the solution on the number line. Okay, so we solve then and we move to the next point. Solve the following equations. Explain the properties you have used to solve each equation. So now we then, 4.3, to solve the following equations, we need to explain the property. So we solve the following equations. Explain the properties you've used to solve each question, show all your work. Now, let us, obviously, now we're going to explain the property we used. Let us look at 4.3.1. Right, obviously in 4.3.1, what we have is we have 1.4x. We have 1.4x, so we write that one down. 1.4x plus 5, which is equal to 16.2. So we have 1.4x plus 5, then we have minus 5 equals 16.2 minus 5. So now we have used the property of what we call the additive inverse. Additive inverse of right. So we use the property of the additive inverse of 5. So additive inverse, so the additive inverse of 5 is minus 5. Okay, that is then we have put up sort of added minus 5 or subtracted minus 5 on both sides of this, which is the addition of minus 5 on both sides of the inequality there.
Yes.
Right. So we continue. So now at this point you subtract and you get this, and therefore that is 16.2 minus 5, and then you have 11.2. 11.2. Right. So in the end then, because now we added, so now you can use your calculator to confirm this. You can use your calculator to confirm these as follows. So then we have the following. We have 16.2 minus 5. Okay, we've seen that in 16.2 minus 5 is indeed 11.2.
11.2, yes.
Okay, and then now the next thing is we're going to have therefore 11.4. 11.4x, which is equal to
1.4.
Sorry, 11, yeah, 1.4, excuse me. I'm happy.
Yes. Okay.
Wait awake. Right. So we have 1.4, and 1.4 is equal to what? It's equal to 11.2.
11.2, yes.
Yes, which is 11.2. Then you take the 1.4x which is 11.2, you divide by 11.2, you divide by 1.4, excuse.
11.
Right,
Yes.
so you have 1.4, you divide,
Yes.
1.4x equals 11.2, divide by 1.4 both sides, and therefore we have the following. Right, so at this point, we perform the division here.
Yes.
Right, so if you have 11.2, you divide by 1.4.
I think I got an 8.
You got an 8. Well done.
Yes.
It is indeed 8. So if you have the 11.2 divided by 1.4, you get exactly 8. So x is
Yes.
equal to 8.
Yes.
Okay, so obviously, see, we're looking at the question, solve the following inequalities and show the solution in a number line. And okay, we're doing actually, excuse 4.3.1, and yeah, okay, because we're to solve the following equations, explain the properties you have used to solve each equation. Show all your work. Right, so obviously to show the, explain the properties we used. Okay, we're to explain the properties. So obviously here at this point to explain, we have actually the additive inverse of minus 5 is 5. So what we did is, in principle, we subtracted 5 on both sides, or alternatively, what we can say is that you add the opposite. So you add the opposite of 5 like this. So and we say, so the property is we've used is addition of the additive inverse on both sides.
Okay.
Addition of the additive inverse on both sides of the equation.
Okay.
Right, so in which case then, so now at this point, it is addition of the additive inverse on both sides of the equation. So addition of the additive inverse minus 5 on both sides of the equation. That's what we've done. And we got this. Now, at this point, we perform division on both sides, but now, strictly speaking, what we say is we multiplied by the multiplicative inverse on both sides of the equation, which means that you have 4, which is 1.4x, which is 1.4 inverse, which is 11.2. Right, so which is multiplication by the multiplicative inverse. Okay, you can say multiplication both sides. Right, so it is multiplication both sides by the multiplicative inverse of 1.4. Right, so multiplication both sides by the multiplicative inverse of 1.4. Multiplication both sides by the multiplicative inverse of 1.4.
Not 1.4.
Yes. Okay, so we continue then. So we're trying out the next question, 4.3.2. You're right. So we need to solve for this one. Okay, 4.3.2 is next. So you have
Yes.
we have 2/3 of y
Yes.
minus 2 equals 20, which is 2/3 y minus 2 plus 2. We add 2 on both sides because we want to eliminate the 2, and the property we use is addition. It is addition. It is addition on both sides. Addition on both sides.
On both sides. Yeah.
Addition both sides of 2. Addition on both sides of the additive inverse of -2.
2.
Yeah, so the addition on both sides of the additive inverse of -2. Note that the additive inverse of -2 is 2. All right, so that you have 2/3y, and you have these, you add them up, and then you get 22, like that.
Yeah.
Next, now we want to remove this coefficient 2/3, and to remove the coefficient 2/3, we must multiply by the multiplicative inverse of 2/3. So now we multiply both sides. So you take 2/3,
2. Yes.
like 3/2, excuse me. Okay, it is 2/3 here, y, and yeah, we multiply by 3/2 here, we multiply by 3/2 there. Right, so in which case the 3 cancels, the 2 cancels, you have y, and the 2 cancels. 2 goes how many times into 22? It goes 11 times, and 11 by 3 becomes 33. You can check that on your calculator. So giving us that if you take 3/2 multiplied by 22, 2 divides 22, giving 11. 11 by 3 gives us 33. And therefore, this one here is something that has given us the result. So what do we say here? So these reasons apply to that part of the calculation, and therefore this one here would be something that is very important. Okay, yeah. So it's multiplication by the multiplicative inverse of that. So it is multiplication.
Okay.
Multiplication both sides. Multiplication both sides of the equation. So you can write that one down here. So you can say it is exactly multiplication. All right, it is multiplication both sides by the multiplicative.
Okay.
Multiplicative inverse. Multiplicative inverse of 2/3. Okay, we considered 2/3, 2/3, and we multiplied, we performed the multiplication.
Yes.
Both sides by the multiplicative inverse of 2/3, because the multiplicative inverse of 2/3 gives us 3/2.
3/8.
Yeah, okay, so the multiplicative inverse of 2/3 is 3/2 because it's just the reciprocal. We also use the word reciprocal, so you can always come across that. All right, so we multiplied both sides by the reciprocal. So obviously the 3/2 is the reciprocal of 2/3. It is the reciprocal of what? Of
Okay.
2/3. Okay, so we continue
2/3.
then. Yes, we continue then to solve the next question. Right, so the next question we're solving is question 4.4. In 4.4, we're considering the idea of a rectangle. And obviously now, a rectangle has a width x and a length 2x minus 1. Explaining your thinking. explaining your thinking.
Yes.
Right. So we continue. Right. So in continuing, we have the following. Right. Okay, right. So now, yeah, a rectangle has a length, has a width x and a length this one, 2x minus 1. Explaining your thinking, describe the length in words in terms of the width. So let us continue right now to look at this particular question here, question 4.4.2.
Yes.
So if you describe the length in words in terms of the width, so the
Yes.
length, we are looking at 4.2, so you can say the length. All right, in terms of the width, so if this is the length, so the length is 2 times or is
Two
twice.
times, yes.
Yes,
Twice
or
the
it's
width.
the width. Yes. So the
Yes.
length is 2 times the width
Yes. Yes.
minus 1.
Yes.
Minus 1. Yeah, so you can say it like that. So you can say
Okay.
the length is 2 times the width x minus 1. Okay, yeah, but it's not the only way.
Yes.
As I said already, one can say the length, which is what? The length is 2x. So we are saying the length is 2x minus 1, but you write it in words. In words, that
Yes.
would include the word width in it. So you can say the length is twice the width minus 1. So the
Yes.
length is twice the width minus 1. Okay, so that's what we have. All right, so that's what we got. And we have described the length in words in terms of the width. Next question. So next question, we're looking at 4.4.2. We need to find the dimensions of the rectangle if its area is 21. Find the dimensions of the rectangle if its area is 21. So we are told that the area, we're looking at 4.4.2, but we're told that the
Yes.
area is 21. But do we know that the area is length?
And breadth.
Yes, and breadth or
Yes.
length by the width. Okay,
Yes.
for the width, so it's like length by the breadth.
Okay.
So we continue, which is 21. What is the length here? The length is 2x minus 1.
Yeah.
The width is what? Is x.
It's X.
So let's distribute here. So we have 2x squared minus x equals 21, which means 2x squared minus x minus 21 equals what? Equals 0.
Yeah. Yes.
Okay, so let's solve here. Obviously, we need to solve for x. And to solve for x here, we need to factorize this. What are the factors of this?
Yes.
Okay, now we can find the factors of this with simplicity. Okay, to factorize a trinomial, this is called a quadratic. It is called a quadratic trinomial,
Okay.
which is called a quadratic trinomial. Okay, so you multiply 2x squared by minus 21. which is minus 42x squared. So now, then, okay, what do we do here? Okay, we need to find the factors of minus 42 when dealt with together.
Yes.
Would give, when dealt with together, would give okay, we see when added together would give minus 21. So what then do we do with this? Okay, right. So what are the factors of this? Okay, they're very easy. Factors of minus 42. Okay, yeah. Minus 7x and 6x. Okay, we've learned from primary school. So now this is minus 7x and 6x. And then if you multiply them, we get minus 42.
Mm-hmm.
So which means that you have 2x squared minus 7x plus 6x. Okay, because the factors of minus 42 that give minus 1 are minus 7x, 6x, and this is minus 21 equals 0. So you pull out x here, and this is x minus 7 plus 6, which is x. Okay, you can pull out a 3 here. Okay, right, we pull out a 3 because if you pull out a 3 out of this, what do you get out of this? So you get a 2. Yeah, so even this one is a 2 here. You get a 2. Okay, because 3 times 2 is 6. 3 times 2 is 6. So if 3 times 2 is 6, then factoring out 3 out of 6, you get a 2x. And you have a minus 7, because 3 by 7 is 21.
Okay.
So we continue. So yeah, we continue. We continue.
All right. I'm gonna have to practice this over and over.
Yes, definitely. But yeah, these are the kinds of things they play with all the time. Okay, then you take the 2x minus 7, and then we have x plus 3, and this is 0. So these become the linear factors. So these ones are called the linear factors of the expression. These are called the linear factors. So that when x is 7 over 2 or x is minus 3. Okay, x is 7 over 2 or x is minus 3. Right, so obviously we know that x cannot be a negative number because we're dealing with dimensions, but also x is the worth. So x equals minus 3 is actually not applicable, or it is certainly invalid. Why? So it is certainly not applicable, or it is invalid.
Okay.
Okay, so which means therefore that x is 7 out of 2, which means x is 3.5. Okay, x is 3.5, and this is the worth. If we together agree that x is 3.5, which is the worth, okay, we can say 3.5 units, what would then the length be? Okay, so
it's gonna be double the amount, double the number.
It's gonna be double the number and 1 less. So yeah, good. So yeah, right. So it's gonna be, okay, yeah, we can write that as you say, double the number. So it is double x minus 1, and x is 3.5 minus 1, and 2 times 3.5, it's 7 minus 1. 7 minus 1 is what? It's exactly 6
It's 6.
units.
Yes.
Okay, because they said find the dimensions of the rectangle if it's 8 is 21. So this means that the length, which is exactly 2x minus 1 equals 6, and the width, what is the width? The width is x, which is 3.5. The width is
Yes.
x, which is 3.5, and therefore we are done. We are done with solving this particular question.
Okay.
So we continue then. We continue then. Okay,
Yes.
next question. Okay, so we have gone through these questions.
Yes.
Okay, but also there are certain things we need to learn as part of our training for this module. Right.
Okay.
Right. So we actually continue then. Evaluate and then express each of the following statements as a general property of operations using letter symbols or variables. So we're going to use what we call letter symbols, which also called variables. Okay, but also we need to evaluate. So there are basic, at least 2 things we need to do, and the marks are 2. So first we need to evaluate.
Okay.
After we've evaluated, and then express each of the following statements as a general property of operations using the letter symbols or variables. So yeah, we did 2 things. We need to find the answer to this each of the expressions, and then after we found the answer, we actually proceed to state the law, the property, the general property
Yes.
of operations. Okay, for example, let's look at 3.1.1. Well, 16 times 97 plus 16
Yes.
times 3 can be calculated mentally and exactly by 16 times 97 plus 3. So, and in this case, if we need to calculate this, what is the answer to this? Because we're told that, okay, the examiner is telling us that this expression, 16 times 97 plus 16 times 3, all in separate parentheses, can be calculated mentally and exactly. So we can calculate in our minds, and we can find the accurate answer by converting these to this. So yeah, the examiner is effectively saying in 3.1.1, is saying, students, note that 16 times 97 plus 16 times 3 is 16 times 97 plus 3. Like this. Okay. Okay. You asked if okay, I did not see your message. You asked if you should use a phone or a laptop. It doesn't matter. Yeah, any of them. My apologies. I saw your message now. Just that, yeah, at the time that I was typing, I was focusing on my laptop. So, but yeah, it doesn't matter. You can use either of them. Because you must be able to see in the end. Okay.
Yeah.
Right. Okay, good. Now, if you have 16 by 97 plus, okay, the examiner is saying this is equal to this, but what law is this?
Yes.
So yeah, let us first evaluate these. So to evaluate
The
these,
law.
yeah, definitely. Let me state the law. Right, what is 97 plus 3? 97 plus 3 is exactly 100, and therefore this is 1600.
Yes.
Okay, so now what is the law, the general property of operations that allows us to do this? Okay, we can study it in reverse, because see, if you have A, B plus C, normally stated like this, it's called the distributive property. Okay, so if you have A times, in brackets, something plus something, B plus C, then it is AB plus AC. And this is called what? It's called the distributive law. It is called the distributive. It's called the distributive law. Okay, this is called the distributive law because you're performing distribution. So you're multiplying from the left, and there's that level of distribution there. That's something that you need to note. Okay, and make sure that you most certainly understand.
Yes.
Okay, good.
All right.
Okay. Right, so we have the following. Okay, yeah. So that is quite distributive law. But obviously, I mean, we ask ourselves the question, have we answered or not? Have we answered or not? Right. Have we answered or not? Right.
I don't think.
Okay. Please, yes, what do you think? I mean,
They
answered
say we should,
3.1.1. What is missing in 3.1.1? Okay, yeah. What do you think?
I'm just thinking. They say we should evaluate and express each of the following statement as a general property. So you said the distributive law is our property now. The law is the one that we're using. I think we have answered it.
Yes, because we evaluated. Have we evaluated? If you found the
Yes.
answer to this, okay? Yes, we found the answer.
Yeah.
Okay, and then
it's 1600. Yes.
Yes.
Then express each of the following statement.
Mm-hmm.
You said the statement is a distributive law.
Yes.
Am I right?
Yes.
Am I?
You are right. You are right.
Yes.
Yes, definitely. So we have expressed each of the following statements as a general property of operations using letters, symbols, variables. We have used the variables, the letter symbols of the A, B, and C. Okay. Yeah.
Okay.
Yeah. Good. So yeah, we're done. I just wanted to make sure that we agree that we have
Yeah.
All right. Yeah. Okay.
We're done with it.
Yeah, we're done. We're done with that one. Okay, we continue. Okay, let's look at the next one. All right. So now if the
Number
3.1.2, 12 cents plus 8 cents have the same value as 20 cents. Okay, so we need to evaluate. Okay, evaluate and then express each of the following as a general property. So 12 cents plus 8 cents have the same value as 20 cents. So,
yes.
Okay, yeah, let's do this one. Okay, in 3.1.2, if you say 12 cents and 8 cents have the same value as 20 cents, what then do we do? Okay, and also, how do we therefore express this one? How do we evaluate this? So yeah, okay, in 3.1.2, you're gonna say we have 12 cents and plus, okay, plus 8 cents. Okay, right. So, okay, 12 cents plus 8 cents gives us what? Gives us 20 cents. We agree. Give us 20 cents. Okay, so now this is true. Now, we're asking the question because they said we need to evaluate. So indeed, we have evaluated, because if we take 12 cents and add 8 cents to it, we get 20 cents. Now, the next question is that we then need to express each of the following statements as a general property of operations using letter symbols. So the second part of the question is we use A plus B. Right, so we can use, it doesn't matter, it doesn't have to be always A plus B. I mean, we can say X cents.
Yes.
X cents plus Y cents. You can use X and Y. And if we had x cents plus y cents, then we get what? We get exactly x plus y cents. Okay, like this. And this x plus y cents can be written as z cents, where z is the sum of the x and the y. So you add two numbers, you get a different number.
Okay.
Yeah, but you can get the same number. Okay, if you add two numbers, you can get a different number. Z, like 2 plus 3. 2 plus 3 is 5. So 2 plus 3 is 5. So and 5 is a different number. So
Yes.
then we're able to see what we're getting there. Okay, so let's have the following. Right, so yeah, that's what we have. So we have, if we do addition, we get a result after addition called the sum.
Okay.
And
Yes.
now we can use letters to show that we're adding x of the cents and y of them, y of the cents, and you're getting x plus y cents there. Okay, we continue then to solve these.
Okay.
Okay, then let's look at the next question. We look at the next question, 3.1.3.
Yeah. Yeah.
Right, 3.1.3 is it's 231 plus 198 in parentheses plus 2 can be evaluated or rather can be calculated exactly by 231 plus 198 plus 2. What has happened here? There was some, okay, so yeah, we can write 231 plus 198. You can just remove the things from the, you can remove the mathematical symbols from the sentence. Okay, right.
Okay.
So yeah, we have 231. Oh, this is recorded once again, even if I'm breaking when I'm talking to you because the network sometimes can fail.
Yes.
But yeah,
Yes.
the recording is perfect.
It's perfect. Okay.
Yes, so the recording is always going to have, because it's recording at my source on my computer, and you'll get
All
like
right.
perfect sound quality. There's not going to be a breaking
I
thing.
was a bit worried about that. I was a bit worried.
Yeah.
Is it gonna be the recording?
Yeah, the recording now is perfect. It's always going to be, because the recording is happening at the source of the sound in the at the presentation studio. So yeah, there's no way there
Okay.
can be an issue. Okay, right. So yeah, if you say these can be calculated exactly by these. So 231 plus 198 in parentheses plus 2 can be calculated exactly by 231 plus 198 plus 2. Okay, this can be calculated like this. That's what the examiner is saying. These can be calculated exactly by this. So this and that can be calculated in the same way. And the examiner is saying, can you evaluate these? Can you get the answer to this? Yes. Okay, let us get the answer to this. Because we have 231 plus 198 plus 2 is what? Is 200.
Yes, 200.
198 plus 2 is exactly what? 200. Okay, now
200.
231 plus 200 would give us what? You know, we can get this one.
121.
Yes, it will be 431.
Yes.
Okay, it's going to be 431. Okay, good. Now, which is 431. And then we then say, these can be calculated exactly by this. Okay, now we have calculated, and the examiner said evaluate. We evaluated, and the answer is 431. We've got the answer. So then what we then say right now is the following. Right. So we need to say the property. What is the property in terms of gender? So you can say A plus B plus C is A plus B plus C. What property is this? What property is this?
Isn't
Okay,
it the distribution?
just teasing you. It is called, okay, it is called the associative.
Associative. Oh.
Yes, associative property. Or you can call it the associative law. Okay, so what does association mean? So association has to do with the grouping. So now we have the grouping of A and B. A and B have been grouped together in parentheses, and we continue to now perform further grouping of the B and the C as well. Okay, so yeah, and this kind of grouping is grouping that is very, very important. So we can, if we have three numbers that we're adding together, somebody gives us 2 plus 3 plus 5. And then it is still 2 plus 3 plus 5. Okay, now we can do this around the 23, and then we can put some brackets. Okay, but you see, it is 2, 3, 5, 2, 3, 5. We're adding them together. And obviously we agree that 2 plus 3 is 5, and 5 plus 5 is what? It's 10. So even 2 plus 3 is 5, and 5 plus 5 is 10. Okay, now we agree together that if we are adding this thing, we're getting 10. But we then perform addition and perform what you call use what you call is association, but we use what you call the associative property. So yeah, what does associative property mean? We associate 2 and 3, and then we shift the brackets now because they're around 2 and 3, and then the brackets are around 3 and 5. So we sort of have shifted the brackets. We have shifted the brackets there. Okay, right. So, and this is called the associative property, or what we call the associative law, because, I mean, it also works with multiplication. If we have A, B, well, we can write like that, but also you can write A, B, C, it is A, B, C, like that. So we therefore get the answer there, and we're excited. Okay, let's continue right now. Okay, we have done 3.1.3. We have evaluated, but also we have stated the law. We have stated the law. Next question.
Okay, before you can go to next question, so basically what I need to do is I need to know and understand all the properties.
You need to understand the properties, okay? The properties of the numbers, like your associative property. We said the distributive property as well, okay? The distributive property, we're able to see that it actually, you know, some students normally use the words, you open the brackets, because if there is A, open bracket, B plus C, close bracket, then there are no brackets on the right-hand side of the equation. Some of the students say you just open up the brackets, because if you have like 2, then 3 plus 5 like this, okay, then what is the answer to this? Okay, the students will then say, okay, this one here is like 2 times 3 plus 2 times 5. Okay, it's obvious, but yeah, there's a law, and this is called the distributive law. So obviously, I mean, we stated that, and you open up. Some students just say you open up the brackets. They use that kind of an expression. Open up the brackets, because now there are no longer brackets on the right hand side of the equation. Okay.
Okay.
Right. So you continue.
Yes.
Good. Right. Let us look at 3.1.4. 13 times 25 times 4 can be calculated mentally and exactly by 13 times 25 times 4, but 25 and the 4 are in parentheses. Okay, so let us evaluate these. First, we need to evaluate. So with 13 times 25 in parentheses times 4. So 13 times 25 in parentheses times 4, this is equal to 13 times 25 times 4. Like this.
Okay.
Okay. Now, the examiner is saying, evaluate this, because the examiner tells us that exactly this one here
is
exactly this one here.
Yes.
Okay. And we've taken this and we actually equated it to this. The examiner saying, get the answer to this. Okay, by good luck, it's easy. Because what is 25 times 4? Okay, 25 by 2 is 50. And by 4 is 100.
100, yes.
Good. And then 13 times 100, all this way easy. You just write the 13 and then you put 2 zeros that way. Okay, so yeah, that is how you multiply numbers. So if there's 100 and then just put 2 zeros there. Okay.
Yes.
Okay, good. So we have evaluated 3.1.4 and this is the answer. Okay, if this one is the answer, but there's a further instruction. What is the further instruction? We need to then express what law is this? That's it. That's the question.
Yes.
What law is this? In terms of letters, A, B, C, or X, Y, Z, just some variables. We can use some PQR, etc. So I'm going to use PQR. We can use X, Y, Z. Let me use PQR.
Okay.
So you have PQ, then R must be equal to P, then QR. Okay, so if you have PQ in parentheses, then you can shift the brackets, which were around P and Q. Now the brackets are around Q and R.
Yes.
And what law is this? That is the question. Okay, so this is called the associative.
Associative.
Yes, it's called the
Because of the grouping. Yes.
Because of the grouping. Because of the grouping.
Yes.
Because grouping is just association. Okay, because
Yes.
it's like saying Peter and John are associated because they are together. They are in the same group.
Yes.
Okay.
Yes.
Then now, I mean, then we shift and we associate the two next. You know, we associate the first two, then we associate the two next, and the grouping is called associative property. Okay, the grouping of the terms. Okay, right. So we have solved 3.1.4. We have solved 3.1.4. Okay, we're done with 3.1.4, and then we move on to 3.1.5. First, we evaluate, and then we state the principle, we state the law, we state the property. Okay, let's look at 3.1.5. Good. 3.1.5 is like this. So this one is an easy mental calculation. Okay, it's an easy mental calculation. So if you take 123 over 298, you multiply by 39 out of 39. Okay, the lecturer is saying, because I've taken these questions from like the past assignments and things, okay, and the exams, but now the lecturer is saying it's an easy mental calculation. He's saying it's straightforward. Okay, if it is straightforward, then they are saying we must evaluate this. But they're saying it's a mental calculation. So if you multiply by 39 out of 39, what is 39 out of 39? Okay, now there are explorations that students can do here. You can launch your calculator to assist you and to save time, but it's to assist you so in sort of the investigation of this. Okay, you can take a calculator and then say, now, what about if you take 123 times 39? 123 times 39, we're investigating. We're getting 4797. Right, we're getting 4797. We're getting 4797. You divide by, right, so next you're getting 298 times 39. 116, 11, 6, 22. 11, 6, 22. Okay, now look. Okay, we can look at this, but this is not nice. Okay, it's not easy to deal with. These are large numbers, first of all, so, and they are nasty. But now we can't easily do this in our heads. 4,797 divided by 11,000. Ooh, it's too much. It's too much. Okay, the thousands are way too much. And they show no pattern at all. So what we do, okay, we take the question by the examiner and we then will cancel this. Okay, the 39 out of 39 divided by 39 is 1. Okay, so that one is easy. Okay, 39, if you divide 39 by 39, what you're getting is what? Is 1, which is easy. Okay, and therefore we're getting 1, 2, 3 divided by 298. Okay, that is the answer to this. That is the answer to this. Obviously, see, you can ask a couple of questions. Can these be simplified? If one is wondering about that, you can launch our calculator. And then you can like punch in the fraction here, punch 1, 2, 3 out of 1, 2, 3 out of 298. Okay, yeah, so we have that. So 1, 2, 3 out of 298. Okay, look. Okay, once you press an equal sign like this, and once you press an equal sign like this, the 1, 2, 3 out of 298 does not reduce, does not simplify, is remaining the same. Okay, you can multiply by 1. You can multiply by 1. Okay, because it's remaining the same, it means that there's no simplification here. The only thing is you can express it by pressing the SD button. You can convert this one because it is a proper fraction, but you can write it as a decimal fraction, but we don't want decimals, so we're good. Okay. So yeah, so we've evaluated this. What is the evaluation? The evaluation is the answer we've got, and this is the answer we've got. Right? So this one is an easy mental calculation. Okay, right. So we've calculated. But we need to state the property. What property is this? What property is this? Right, so now, right. Okay, yeah, what property is this? Okay, we're gonna state the property. We're gonna state the property. Okay, the property is a very straightforward property. What property is this? Yeah? Never mind.
I'm not sure. Is it not a division or?
Yes, it is division because we performed some division of 39 by 39. Okay. So yes, it is division. So now you can state something like this. You can say like A divided by B, like A divided by B, because we're using letters. And then now this number must be the same as this number. So you can say like C over C. And then the C cancels the C, and it becomes A over B only. Because the C over the C, what is C over C?
We said it's 1. It's C.
It's 1.
Sorry, it's C.
Yeah.
Sorry, it's
Never
C.
mind. Never mind. Never mind. Okay. Once again, this is recorded. This is recorded, but the recording will never have breaks in it. It will always have perfect sound quality. So you have A over B. If you divide C by C, you get a 1, and it becomes A over B.
Yes.
It becomes A over B.
Right.
Right. So this is what we have. Okay, because the A over B times 1. I mean, if you multiply by 1, it becomes just A over B. So in the end, then what you're getting?
It's not changing.
Yes, it's not changing. And so the property is therefore that this is called the cancellation property. Right. So this is the property. But now if C over C is called the cancellation law. Right. So this one is called the cancellation law. If you don't want to call it the cancellation law, it's called it the cancellation property. And then also you can have C over C.
Okay.
Yeah, okay,
So
so
each time when a number cancel another number, it's a cancellation law.
yes, it's called the cancellation law. Okay, because that is the law that allows people to like cancel in mathematics. If the law wasn't there, then we wouldn't cancel things. Okay, we wouldn't cancel numbers.
Okay.
So it's called the cancellation law. And then also there's another law. What law allows us to convert this to this? What law allows us to multiply things by 1 and the things do not change? Okay, so there's a law in mathematics that allows us, if you multiply something by 1 and the thing does not change, and it remains the same. So there's a law that does this. What law does this?
Yes.
Okay, the one is called the multiplicative identity. So it is called the multiplicative identity property.
Okay.
Okay, yeah, it's called the multiplicative identity property, that when you multiply by 1, okay, like when you say 2 times 1, the answer is 2. Or you say 3 times 1, the answer is 3. Why is it that when you multiply any number by 1, then it does not change? It remains the same. That is called the multiplicative identity property.
Okay.
Multiplicative identity property. Okay, yeah, that's what we have there. So but now we used cancellation property to remove the C. Okay, but obviously the question said evaluate, and with evaluated.
Can I stop you there?
Yes.
The identity property, does it come into like in your multiplication and in your addition?
Yes,
Remember
well
when
done,
you
well
add
done.
your 5
Yes.
plus
Yes.
0, it's still 5. Okay.
Yes,
All right.
well done, well done. Yes, it comes also when dealing with addition. Okay, there's something we call the additive identity on that note, just to mention. Okay, right, there's something we call the additive identity. Right, so the additive identity is as follows. Identity. Okay, right. So now we're saying, for example, I mean, like 2 plus 0 is 2, or 5 plus 0 is 5. Okay, it's a property of 0 that 0 does not change numbers under addition. So if you add 0 to any number, you get the same number. So this is called additive identity property. Also, yeah, 5 and 0 you would give the same results. And so, yeah, okay, yeah, but also it applies to multiplication when you multiply. So it's either the multiplicative identity property, or you can call it an additive identity property when you're dealing with 0. Yeah, you're right. Dealing with 0. Good. Let's look at the next question. 3.1.6. Oops. Okay, never mind. Right. Let's look at 3.1.6. Okay, 3.1.6 is as follows. Okay, 3.1.6. 0 divided by 23. Okay, now if you take 0 and you divide it by 23, and we have 13, you divide it by 37. Okay, this is 3.1.6. That's the question. Okay, so, okay, 0 divided by 23 plus 13 divided by 37 is an easy, okay, the examiner is saying it's an easy mental calculation. And they're saying it's an easy mental calculation. So what does it mean? The examiner is saying don't use a calculator. Just do it mentally. So, all right, so let's do this. Okay, but first we need to evaluate this before we state the property. Now let's evaluate this. What is the answer here? 0 divided by 23 is a 0.
It's a 0.
Okay, so 0 plus 13 out of 37 is what? Is 13 divided by 37. All right. All right. Okay, good. Now, So yeah, we evaluated these and this is the answer. Okay, but mentally, so yeah, they say somebody can come and say 13 divided by 37 can be calculated. I mean, we know as a decimal, it's 0 point something. We need only a manual calculation. Okay,
Yes.
what can we use some general property of operations using letter symbols, variables? Let's use some variables. So here we shall say 0 divided by A plus B divided by C.
Yes.
And then what is 0 divided by A? 0 divided by A
It's 0.
0. Okay.
0.
But under one condition, and then 0 plus B of C is B of C. Under one condition, what is that condition? The condition is that A is not 0.
Okay.
Okay. The condition is that, okay, good. The condition is that A is not 0. A is not 0.
Yes.
Okay, so yeah, A is not 0. A is not 0. Okay, because why? Why are we saying A is not 0? Because if you divide 0 by 0, this one is undefined. Okay, so 0 divided by 0 is undefined, or we say it is indeterminate. Okay, so it is called an indeterminate form in mathematics. Okay, this is called an indeterminate form. So if you divide 0 by 0, you have an indeterminate form, and therefore we must if you are to say 0 divided by A, it can only be 0 if the denominator is not 0. Okay, because it can only is true, like 0 divided by 2 is 0, but once again, 0 divided by 0 is undefined. Okay, so that's something we need to just remember. So, okay, we've evaluated. First, we must evaluate the 0 out of 23 plus 13 out of 37. We evaluated and we got the answer 13 out of 37. And then the property. In terms of the law, in terms of letters, in terms of variables, and the answer is just B of the C there.
Okay.
Okay, we continue. We continue.
Yes.
All right, next question.
3.2.
Yes. Give the name of each of the properties illustrated in 3.1, okay, yeah, in 3.1.1 to 3.1.6.
Yes.
Okay, yeah, now they need the names. Okay, yeah, we were stating the properties, but yeah, they need now the name of the properties. What are those properties? Because we were just writing. What are those properties? So we would remember in 3.1.1.
Yes.
We said that the property was what? So we have A, and then we have B plus C. Okay, so if you have A open brackets B plus C, because you have A open bracket A in brackets B and C, and then it is equal to AB plus AC. Okay, so what is this?
It's our distributive.
Yes, it is called the distributive property. It is called the distributive property. Well done. It is called the distributive.
So on this question, if it comes like this, I should also write the symbol letter first before I give them the answer. The name
of the property. Yes, definitely.
Okay. So
Good.
it means one is for naming, and the other one mark it's for giving the symbols.
Yes, most
Later.
definitely. Yes, true. Good. Right. Yeah, let's look at 3.1.2. Okay, we said 12 cents, like A plus B is property C. What property is this? What property is this? It is called the equality property. It is called the equality property, because if you're adding 12 and 8 and you're getting 20, why is 12 plus 8 equal to 20? They are equal because it's called the equality property. Okay, so you can call it here the equality property.
Okay.
It is called the equality property.
Property.
Yes, the equality property. Okay, next, 3.3. Okay, this one, now you're going to do 3.3. Okay, 3.3 now you're going to do, there's some brackets around here. You start with the brackets. So you start with the bracket and then you have plus B and then you have C. And then now you have A plus and then B plus C. What is this one? It's called the associative property. It's called the associative property. Okay, that is what we have.
Okay.
Next. Okay, now you have this calculated mentally by this. So you have A, B plus C, which is, okay, now let us do it here, the 3.4, let us do it up here. Okay, now you are doing 3.1.4. Okay, in 3.1.4, we start with a bracket, and then we have two things like A, B, C, and then you have A, B, C. Okay, this is called the what? It is called the associative property as well. Yes, because it's grouping. So it is called the associative property. It is called the associative property. Associative property. Next, let's look at 3.1.5. Okay, this one is an easy mental calculation. Okay, yeah. Okay, it's an easy mental calculation. So we said that if you have 0 divided by, okay, we're looking at 3.6. If you have 0 divided by A plus B over C is B over C. Okay, so this one, what is then the property here? What is then the property here? Right, so this one here is, there are a couple of properties because, okay, excuse me, it is 0 here. Okay, you see, if you add 0 plus whatever, and you get a number, it is what you call the 0. 0 itself is an additive, identity because we have already said that what we're gonna get here is 0 divided by A plus this is 0 plus B over C, which is B over C.
B over C.
Okay, so in the end, all right. So the 0 so the property that it is the 0 itself as what? As an additive identity. So
Identity,
yes, so you have the additive identity property. Right, so you have the additive identity property. Okay, yeah, additive identity what? Property. Right, so we continue. All right, so we continue, right? So yeah.
Yes.
All right, so yeah. So we studied the properties. Okay, that is 3.1.6.
Yes.
Okay, I jumped one of them. I jumped 3.1.5.
I think you skipped 3.1.5.
Yes, we skipped 3.5. Okay, good. So yeah, this one is 3.1.6 of the zero, zero itself. When you're adding by zero, etc., and the whole thing is 3.1.6. This one. Okay, let us take 3.1.5. We said that if you have, yeah, okay. We said that if you have A divided by B and you multiply it by C over C, which is A over B. Okay, now this one, we then said that, okay, if you have C over C, what is C over C? It's a 1, which is A out of B. Okay, yeah. So, okay, if you multiply by 1, okay, it becomes A over B. It's called a multiplicative identity property.
Identity.
Yes, multiplicative. Okay, so there are two properties, the cancellation property, but now what arises is the multiplicative identity. Multiplicative identity property. Identity property. Multiplicative identity property. Multiplicative identity property, because the one is a multiplicative identity, okay? Because under multiplication, the one does not change things. It does not change entities. Next question. So yeah, we've done all of them. 3.1 to 3.1.6. 3.1.1 to 3.1.6. Next question. Right, so we have done this. Okay, let's just look at this question about expressions. Express each of the following problems using an equation. So we need to use an equation with one variable. Like this one is about Noma Sizwe. Yeah, Noma Sizwe. Noma Sizwe has like 70 Rand and 50 cents. And wants to buy a movie ticket, which costs 120 Rand. How much more does she need? How much more does she need? Okay, let's do it. Noma Sizwe has 70 Rand and 50 cents and wants to buy a movie ticket, which costs 120 Rand. How much more does she need? Okay, let's just continue now.
Yes.
Let's see what Noma Sizwe is. How much does Noma Sizwe need here? But now, express each of the following problems using an equation with one variable.
Okay.
Okay, so we just need to express each of the following, and obviously, how much more does she need? So we can let X.
Yes.
Let X be the amount of money.
120.
Yes, the amount of money. Okay, I know that you are way ahead, Betty. All right.
Sorry.
That's fine. That's fine. X is the amount of money. Let X be the amount of money that
she needs.
That Noma Sizwe, yeah, that she needs. That Noma Sizwe needs.
Yes.
Okay, let X be the amount of money that Noma Sizwe needs. Okay, so if you then say you express each of the following problems using an equation with one variable. So Noma Sizwe has 70 Rand and wants to buy a movie ticket, which costs 120 Rand. How much does she need? So Noma Sizwe has exactly 70 Rand, 50. And she wants to buy a movie ticket. She needs more money. So she has 70 Rand, but she needs more money, X, so that she's able to make and have 120 Rand.
Yes.
So we have to express each of the following problems using an equation. So we can also be in a position to evaluate this and say, out of the 120, we minus 70, 50.
Yes.
Okay, what is 120 minus 70?
It's gonna be 49.50 rand.
Okay, I think you're good. Let me
Yes.
see.
Mhm.
Well done. Yes, it is exactly 49 rand and 50 cents.
Yes.
Meaning that in essence, Noma Sizwe needs 49 rand and 50 cents. Okay, so
Yes.
it is exactly what is needed. Okay, so which is 120 minus 70.5, which is 49 rand 50. 49 rand 50.
Yes.
So in other words, she needs 49 rand 50. But we have expressed, because the question was express each of the following problems using an equation. Equation means there must be an equal sign with one variable, and there's the variable, and the variable is x. And the x is the amount of money that Noma Sizwe needs. Okay, so we're good with that one. Let's try the next. Let's try the next question. Right, next we're looking at 2.1.2. Lee K has 8 animal toys and received 3 more. Okay, but Lee K has 8 animal toys and received what? 3 more.
3 more. Mm.
How many does she have now? Okay, we're good. So
yes, good.
Looking at 2.1.2. Lee K has 8 animal toys and received 3 more. How many does she have now? Let's express this one is an equation. So let x, right, so we let x be equal to the number of animal toys, number of animal toys that Lee K, yes, that Lee K has. Okay. Right, so if this is true, then we have x equals, Lee K has 8 animal toys and received 3 more, has 8 animal toys and received 3 more, and 8 plus 3 is what? It's 11.
It's 11.
11 animal toys. Okay, it's 11 animal toys. Okay, good. So obviously, I mean, that is the situation, but obviously the question is, express each of the following problems using an equation with one variable. So we need a variable, and the variable is what we want, what we need to determine. So obviously we agree that Lee K has a total of 8 of these animal toys and received 3 more of them. So 3 more, then it's going to have 8 plus 3, which is 11. So x is the unknown, is the total number of the animal toys that this Lee K has, and therefore I believe it's a young person who is playing with toys, and now has 11 toys, has 11 animal toys. Okay, now I know children love toys. I loved toys when I was still small. I loved toys when I was still small. I believed you did as well. But the minute
I did.
Excellent, because they sort of teach you life. I mean, you have a doll, and imagine that now you are a doctor, you are a nurse. I mean, the dreams were big when kids were small.
Yeah.
I dreamt of being many things. I dreamt of being a police officer, being a teacher, being this. So it's all those dreams that, you know, okay, and then we plan ahead. Okay, let's look at the next question.
Yes. Okay.
Right, once again, the recording is always perfect. Darlene is a teacher. She bought 10 boxes of colored markers for her learners.
Yes.
Each box has 12 markers. She packages them into bags for each of her 30 learners. If each learner gets the same number of markers, how many markers are in each bag? Let's talk about Darlene.
Okay.
And Darlene is a teacher. So what is the question? If each learner gets the same number of markers, how many markers are in each bag? So let X be the number of markers in each bag, because that's the question. The question is, how many markers are in each bag? So let X be equal to the number of markers in each bag. Okay. So now we need to find X. If Darlene is a teacher, she bought 10 boxes of these colored markers and for her learners. But now you need to use, express each of the following problems using an equation with one variable. So let us do this. Let us do this. So now let's talk about Darlene. So yeah, it's a very interesting. So X equals, okay, right. She bought 10 boxes of colored markers for her learners. Each box has 12 markers. Right, so each box has 12 markers. She packages them into bags for each of her 30 learners.
Yes.
So it's 12 by, okay, let's look at this. So if you have, each box has 12 markers and she bought 10 boxes. So if you have 10 boxes and there's box 1, box 2, box 3, and box 1 has how many markers? Each box has 12 markers. So this one has 12 markers. Okay, and this one is 12 markers. 12 markers. Box 3 has 12 markers. And until, how many boxes are there? There are 10 of them, 10 boxes. So there's box 10, and box 10 is also 12 markers. See, the question we're asking, how many markers are there? Because if each learner gets the same number of the markers, so we need to know how many markers are there. How can we find out the number of the markers? Box 1 is 12 of them. Box 2 has 12 markers. Box 3 has 12 markers. Box up to box 10. Box 10 is also 12 markers. So how many markers are there? So you'll take the number of the markers per box times the number of boxes. So which means that it's 12 by 10. Because it's 12, you can add all of them. You have, in box 1, you have 12 markers. So you have 12 plus, box 2, you have 12. So you're adding all the markers and you're adding this one. So it's the same as saying 12 by 10. What is 12 by 10? Is 120.
It's 120. So it's a multiple of 10.
Yes, the multiple of 10. Well done. Thank you so much. Yes, the multiple of 10.
Yes.
Yes. And then how many learners are there? She packages them into bags.
We have 30 learners. So learners are 30. Yes. I think we're gonna take them 120 divided by 30 learners.
Well done. We shall take the total number of the markers. So 120 markers altogether. Okay,
yes.
120 markers, which is sort of the total. Okay.
Yes.
This is the total. Then we divide by the number of the learners so that they can share equally. Okay. Equally. And then yes, we know that there are 30 learners, and therefore we would get these. And then if you divide these, we would actually be able to get the answer. What is the answer here?
It's gonna be 4 markers per learner.
It's gonna be 4 markers per learner. Well done. So it's 4 markers. Because the question was, if each learner gets the same number of markers, how many markers are in each bag? 4 markers in each bag.
Each bag. Yes.
4 markers in each bag. Or you can say 4 markers, as you said, 4 markers per learner.
Yes.
We have 4 markers per learner. We have 4 markers per learner. Okay, good. We have 4 markers per learner. All right, let us do the translation of the next questions. So we have done the question about Darlene as a teacher. or Darlene is a teacher, and we've solved the problem about Darlene and the learners and this and the sharing of the markers to make sure that each learner gets the same number of the markers there. Okay.
Yes.
Translate the following equations, 2.2. Translate the following equations into words. Into words.
Yes.
And explain what the equation means in your context. Let's translate 2.2.1 into words. Okay, now if you look at 2.2.1 into words, so
Yes.
E is 2L plus 2L minus 2. Let's translate this one into words. Let us do a quick translation of these into words. So into words,
Can I try it?
Yes,
Can
please.
I try it?
Yes, please try.
It's gonna be E.
Yes.
It's equals to 2 length.
Yes, it's equal
Plus
to
is
2.
plus 2
Yes.
length plus 2.
Yes. Yes. 2. Okay, we can say 2 times L.
Yes.
Plus,
Yes.
okay, plus. It doesn't matter. There are many ways of putting this.
Yes.
Okay, so E
Right.
is equal to 2 times L plus.
Yeah.
Okay, I mean, I'm just making.
Plus 2.
I want to. Yeah, I want to make that the the writing in words a bit more simple. Okay, and easy.
More simple.
Yes. Okay, so E is equal to 2 times L plus
Yeah.
plus 2
Plus 2. Yes.
times okay, now this one is 2 times what? Okay, so now there are many ways. Yeah, what do you think? 2 times. So how do you read this in words? How do you read this in words? That's the thing. So we can say plus 2 times open bracket.
Oh,
Open bracket.
okay.
It's more direct. Open bracket. 2 times open bracket L minus 2 closed bracket.
Closed bracket. Okay.
Closed bracket. So now this one is, I mean, there are many ways, but one way to say E is equal to, because I want to make sure that if a person reads this, they can be able to write the mathematical equation without seeing exactly. So we can say E is equal to 2 times L plus 2 times plus, yeah, okay, yeah. E is equal to 2 times L plus 2 times open bracket L minus 2 close bracket.
Okay.
Okay, yeah. And therefore, this is exactly, it's done. But I mean, there are many ways that are nicer, but yeah, I wouldn't want to get into controversial short ways that can be tricky for somebody to even convert into the words. Okay, now let us look at 2.2. What can you say about 2.2? So in 2.2, you have A, B times B minus 2 in brackets. How can you write this one in words? We say A is equal to, A is, this is how we read it. So A is equal to B times, open bracket, open bracket, B minus 2, closed bracket. Close or closed bracket. Okay, so now A is equal to B times open bracket, B minus 2 close bracket. I feel using the brackets makes it more accurate. But I mean, there are ways somebody can say A is equal to B times. But you see, if you say A is equal to B times B minus 2.
But I think when you showing that the open bracket, you are giving them a light that when you write, there's a need for you to put bracket. If I say A is equals to B times, no one would know if there was a bracket or it should be a bracket. So I think by us saying open bracket, We are giving them the light. There is brackets in between.
Well done.
Because remember, again, we also have 1 plus 2 times 3.
Yes.
Without brackets. Yes.
Yeah, that is true. That is true. Yes.
Okay.
Thank you so much. Right.
Right.
Yeah, it is an average of 2 hours of our discussion. It's just 8:03.
Yes.
So, yeah, it's enough for today, but yeah, the rest of the stuff and much more, we'll do it in our next discussion. Okay, because it's 8:04.
Okay, thank you so much, because I also need to prepare myself for work now.
Yes, that's the thing. It's just
I'm
after
starting work at 9.
Yes, that's fine. Okay, thanks. Yeah,
Okay.
that's it. I'm gonna send you the link to the recording in the next few minutes.
All right.
Yeah, so that you can watch during your time. Thanks a lot, dear. And until next time, yeah, you let me know when else we can meet again. Okay.
Yes, I will let you know. Yes. Thank you so much. Thank you.
Thank you so much, and have a good morning and goodbye.
All right. Bye. Enjoy your day.
And you too. Goodbye, dear. Goodbye.